This lesson is for 4th grade. This is Chapter 9, Lesson 2, Measurement. It's in our short lesson over properties of matter. In this lesson, we're going to discuss how to measure matter, talk about some different things. Some vocabulary that we'll hear is metric system, length, area, density, weight, and gravity. Let's hop to it. So in the last lesson, we talked about how to describe matter using its properties or its characteristics. In this lesson, we're talking about measuring matter. How do we measure matter? Well, we can measure matter using a couple different things. The thing that we usually use is something called standard units. A standard unit is a measurement on which people agree upon. Standard units can be centimeters, they could be inches, they could be tablespoons or teaspoons, they can be cups or pints. That's something that everybody can agree upon. We always know that they're going to be the same, no matter where you are. Many people in the United States use the standard units, again, inches, pounds, ounces. Those are some examples. Scientists use standard metric units. They use something called the metric system. It's based on units of 10. It uses the prefixes such as kilo, centi, and milli, like kilometer, centimeter, millimeter, kilograms, milligram, milliliter, different words like that. But they're all based on units of 10. It defines the size of the measurement. For example, 1 meter is divided into 100 centimeters. Like a century, the same prefix, centi, means 100. So 1 meter is 100 centimeters. There are 1,000 meters in a kilometer, and so on. Everything's based on units of 10 in the metric system. It's commonly used again by scientists and in Europe. Length and width. An object's length is the number of units that fit from one end to the other. That's the length. The width is the number that fits across. How wide is it? How long is it? Area describes the number of unit squares that covers that surface. And the easiest way to find area is to multiply its length times its width. So area equals length times width. So for example, if we want to find the area of the crayon, you would say area equals, and we'll fill in the blanks, the length would be 4 inches times, let's say it's 1 inch wide, 4 times 1, area equals 4 inches, excuse me for getting off the screen there, it would be 4 inches squared, because you have inch times an inch, so they're inches squared. Easy to find area. So what if the shape's not a rectangle? This works better for rectangles, squares, and so on and so forth. Divide it into smaller squares, find the area of each smaller shape, and then you just estimate some of the parts. So it won't be exact, but you'll take estimates. Then add each of those smaller shapes to find the total area. So that's finding area. How do we find volume? We talked about volume in the last lesson. Volume is the amount of space in the object. To find volume of a rectangular solid, we kind of do something similar to what we just did. We do volume equals length times width times height. So you add in an extra step. If the solid's not a rectangle, you again have to use water. We've talked about before in the previous lesson. You measure the amount of water in the container, submerge the entire object in the water, and subtract the original level from the new one. So, example again, say you put an object in and it started at 27 milliliters. You add the object and it goes up to 29 milliliters. The difference would be 2 milliliters. So to find volume with the squares, you do the same thing as you did before. Say we added in the extra element of height. with the crayon, and it was also 1. 4 times 1 times 1 would still be 4, but it would be inches cubed because you have inch times inch times inch. To find volumes of liquids, just use your measuring cups, spoons, beakers, graduated cylinders, and read the markings on the container. So that's a couple ways to measure matter using length and width, area, and volume. Now let's talk about density. So what is density? Density has a lot in common in assisting you, helping you find out about buoyancy. We'll get there shortly. So imagine a plastic ball will float on water. You fill that ball with sand, and it's going to sink. So why? The volume of the ball is the same. It takes up the same amount of space, but you changed its mass, adding stuff on the inside, adding sand and replacing the air, gave it more mass. It has more mass than air. The relationship between mass and volume is density. Again, density is also the amount of matter in a given space. Scientists define density as the amount of mass in a unit of volume, so there's quite a few definitions there. Density also, it describes how tightly packed the matter is in the object. To find density equals mass divided by volume. If the mass is measured in grams and the volume is measured in cubic centimeters, if you remember from the last page, length times width times height, your answer is going to be in cubic centimeters. The result will then have a unit of grams per cubic centimeter. Okay. So let's say, for example, we're going to go back to our crayon. We'll fill in some blanks, and we'll have to make some stuff up. It's to find the density of the crayon. We know that the crayon's volume, with our made-up numbers from the last slide, showed that it was 4 cubic centimeters. Let's pretend that its mass was 8 grams. Making that up. So that tells us 8 divided by 4 will get you 2. And then we're going to move the grams in cubic centimeters over here, which will give you 2 grams per cubic centimeter. There's your answer. Just easy division and moving the units in place using that slash. Okay? That tells you how dense an object can be. The density of the object affects its buoyancy. Remember from the last lesson, buoyancy is the upward force of the liquid or gas. So consider cork and water. The density of water is 1 gram per cubic centimeter. The density of cork is 0.24 grams per cubic centimeter. Does cork sink or float? Well, how you find out if the object floats when its density is less than the density of the liquid or gas it's placed in. Since the cork is 0.24, and I know that number is smaller than 1, which is water, that tells me that the cork is less dense and thus is going to float. Liquids can also float on top of water too, such as, that's why they say water and oil don't mix. Try the experiment sometime. Can you change the density of matter? Sure. If you add heat, as you can see here with the hot air balloon, particles are going to move faster and faster, making them less dense, spreading out, and then heat rises. When you cool it down, they're going to slow down, and then the hot air balloon goes down. So that explains how you're using density and heat, making the object less dense to rise, making it more dense to float, or to go down, excuse me. So that is density. Finally, what is weight? A lot of us always get so confused between weight and mass and thinking they're similar, but they're not the same thing. It's another way to measure matter, but again, not the same thing. Mass is the amount of matter in the object. Weight measures the amount of gravity between an object and a planet, such as Earth. So it has a lot to do with gravity. You use a tool called a scale to measure your weight. Gravity is the force or pull between all objects. It's that force that's pulling you that way, pulling you down. So how are weight and mass related? Well, the force of gravity depends in part on the object's mass. The more mass you have, the stronger the pull of gravity. The stronger the pull of gravity, the more you weigh. So that's why if, say, you see an object like the beach ball, one's filled with air and one's full with sand, the inside has more matter inside of it. If it has more matter inside of it and more mass, gravity will pull stronger on it, pulling it down, thus making it heavier. Unlike mass, though, an object's weight's different on other planets and the moon. The pull of gravity on the moon is about 1/6 as strong on Earth. So don't say the moon doesn't have gravity, it's just 1/6 of the pull. So an object's weight on the moon is only 1/6 of its weight on Earth. So that's saying, say you weigh 100 pounds on Earth, if you went to the moon, you would be 1/6 of that, so you would be about 16 pounds. Well, again, you check weight with a scale, you check mass with a balance, that's how you measure it. Weight is measured in ounces and pounds, those are the English units. And the metric unit, again, the metric system is based on units of 10, that is called a Newton. You use newtons in the metric system for weight. So we talked about a few things in how to actually measure matter in this lesson. Talked about weight and density. We talked about area and volume and the different formulas. We talked about the metric system. There's quite a few things there. You may have to watch this a couple times to let it sink in, but watch it carefully and listen. If you have any questions, feel free to leave me comments in the comment section below, and students may message me on Edmodo.